6:35. So let's get started with today. Quick mic check. Can everybody hear me?
Yep.
Awesome, perfect. All right, so today's going to be pretty similar to yesterday. We'll start off with some review from last night's problem set. I have some pre-selected problems. If you want me to go over anything specifically, feel free to ask, and I'll be more than happy to go over it. After review, we'll jump right into lecture, and then after lecture, I will let you guys go and to get started with pair programming. So today is Thursday, so today is the last day for pair programming. So I will try to finish everything by 7:30, so you guys can have like an hour and a half for pair programming. I think that should be doable since lecture isn't too big today. So yeah, let me get started. Let me share my screen so we can get started. Of course, if you guys feel like I'm going too fast, just let me know and I'll slow down. Like, please let me know if I'm going too fast. So yeah, as always, I will start us off with the 3-step approach that we should always use whenever we encounter a coding problem. Step 1 is to read the prompt and put it in your own words. This really helps to make sure that you understand what the question is actually asking of you. Some questions are worded weirdly, some questions are just vague in general, and for some questions you might not even know what the concept is, right? So for situations like that, what you can do is take a look at your test cases, which is your given input and your expected output, and see if that aids in your understanding of the problem. If you're in like an interview setting, this is where you can have like a conversation with your interviewer, and they'll make sure that you understand what the question is, fully understand what the question is about before you get started with your approach. Step 2 is to come up with a high-level overview of your approach to the problem. So this high-level overview doesn't need to be in code. It could be in pure English, or it could be a combination of code and English. Completely up to you, whatever you're most comfortable with. And if you're in like an interview setting or even on your own, feel free to write your high-level overview down in the editor itself. This may help save some time later on, especially if you're working on a question that was initially vague to you. It can get very easy to get lost in your approach when you're doing the actual coding. So step 3 is to take your high-level overview and turn it into actual coding. Actual code. So seeing those 3 steps in action, this question is asking us to write a method word length that takes in a sentence string and returns a hash where every key is a word of the sentence and its corresponding value is the length of that word. Okay, so not really too much to misinterpret over here. We're just going to be given a sentence in the form of a string, and we're expected to return a hash where every key is a word on the sentence and its value is the length of that respective word. So over here on line 5, we're passed in the string this is 1, and we're expected to return a hash containing the keys of the string this pointing to 4 because this has 4 characters, a string of is pointing to 2 because is has 2 characters, and a string of fun pointing to 3 because fun has 3 characters. Let me just put this on the new line so we can see all that. So what we'll do for this one is we'll split this on the space. So we have a string, we'll split it on the space. And the reason we want to split it on the space is because to know when one word has ended and another one is about to start, in the English language, we use space, right? And I'm pretty sure almost any language, you use space, right? So we'll split this on the space so that way it'll break this string up into 3 different words. So it'll the dot split will return us a new array where it'll have 3 elements. The 3 elements are going to be this, is, and fun. What we'll do once we have that array is we'll iterate through that array. At each iteration, we'll grab the word and we'll just shove it into a hash and we'll assign it the value of its length. We'll just choose the dot length method because that is what returns the length of a string. So we'll just return the hash once we're done iterating through the entire array. So jumping into step 3, let's go ahead and call this, we'll just call this hash lengths because it's going to store the lengths of words. So we'll just set it equal to an empty hash. And then we will also split that sentence string. So we'll do words is equal to sentence dot split. And we want to split this on the space. So once we have that, we want to iterate over that words array. So we'll do words dot split. Curly's over here because it could be a one-liner, and each element inside of our words array is a single word. So we'll call our block parameter word. And now all we want to do is grab our length array, create the key of word, and assign it the value of the word length. And it'll do that for every single word. And once that's done, our hash should be in the form that we need it. So we can just do return lengths. So we give that a run. And you'll see we get this 4 is 2.3, 1 4 into down 6, 3 5 2 out 3. Awesome. Any questions about this one? I don't see anything coming into the chat. And nobody got muted. So I'm gonna assume there are no questions. So I will hit reset and we'll move on to the next one, which is frequent letters. So this question is asking us to write a method frequent letters that takes in a string and returns an array containing the characters that appeared more than twice in the string. Okay, so not really too much to misinterpret over here. We're just going to be given a string. We want to return all the characters that appeared more than twice. So we're given the string of Mississippi, line 5, and we're expected to return an array containing just 2 strings I and S. So we include I because there's 4 I's in Mississippi. So there's definitely more than 2 I's. So we include I. And there's also 4 S. So we include S. One thing to note over here is that we do not include the P's, right? Although there's 2 P's, they didn't appear more than twice. There's not more than 2 P's. So we don't include that in our array. So same thing down here for bootcamp. The only repeating characters there are these 2 O's. There's only 2 O's. There's not more than 2 O's. So they don't get included in the array and nothing else repeats. So there's nothing else in the array. So we just return an empty array. So for this one, what we'll do is we'll use that same pattern from last night's lecture, where we use a hash to keep track of the frequencies of characters inside of a string. Once we have the hash constructed, we'll iterate over that hash. And we know that at each iteration, we're going to be looking at a single key value here. At each iteration, a key is going to be a character, and the value is going to be the frequency of that character. We'll see if the frequency is greater than 2. If it is, we'll just go ahead and grab the character and add it to an array. Since we're expected to return an array, we'll go ahead and add it to an array. And then after we're done iterating through the entire hash, we should have everything that we need. So we can just return that at the end. Oh, can everybody hear me just fine? Or do I sound muffled?
You sound a little muffled, but I can still hear you fine.
Just give me 1 second. I do have a fan on. Let me see if that helps. Any better?
Yeah, I think that's better. Thank you.
Oh, okay. Yeah, sorry, it was just a fan. Sorry, I should ask that at the beginning of class. Okay. But did everybody get the approach that I said? Did you guys hear that?
Yep.
Okay, awesome. All right, so yeah, let's jump right into it. So we'll start us off with that hash. So we'll do counter is equal to hash dot new, and we'll pass in the default value of 0. Now what we want to do is iterate over the string that's passed in. So we'll do string dot each underscore char curly's. This could be a one-liner pipes, and we'll call it block parameter char. At each iteration, a single element is just a character. So we'll do counter at the key of char plus equals 1. And if I just do a return counter over here real quick, and we give this a run, you'll see that we get this hash of m pointing to 1, I pointing to 4, s pointing to 4, and p pointing to 2. So all the frequencies of each of these characters inside the string, and the same thing happens down here for bootcamp. So what we want to do now is iterate over this hash. So like I said, at each iteration, we'll be looking at a single key value pair. So for the first iteration, we'll be looking at m and 1. We'll see that 1 is not greater than 2. So we won't do anything with m. We'll just move on to the next iteration. We'll move on to I and 4. And we'll see that 4 is greater than 2. So we'll go ahead and grab I and we'll add it to an array since we're expected to return an array. And if you look inside of our expected output, inside this array, the first element is I. So we're on the right track. So we'll continue with this. We'll go ahead and call this array. I'll just call it results. If you're in like an interview setting, please think of a better variable name. I just don't want to spend time doing that. So now what we want to do is iterate over that hash. So we'll do counter dot each do pipes and. So in last night's lecture, you guys saw me do this, right? Key, comma, val. Like this is what I call my block parameters. But we do want to give our block parameters meaningful names, right? So over here at each iteration, inside this hash, a single key is going to be a character, and the value is going to be the frequency of that character. So we'll just call this FREQ. So now the code is just going to be if the frequency is greater than 2, we'll put our end keyword. We just want to grab our results array and shovel in the character. Nice. And then at the end, we just want to do return that result array. So we give that a run. And you see we get IS and an empty array. Awesome. Any questions about this one?
So do you use hash.new for the counter because when you put something into it, it stores both a key and a value for what you're counting?
So we use this hash.new because it allows us to change the default value. Even if we didn't do it this way, we would still be able to store key value pairs inside of a hash, right? Like if I just comment this out and we do counter is equal to an empty hash, I can still do counter at the key of j is equal to 1, right? And if I just comment all of this out and we just do return counter and we give this a run, we'll see that j points to 1, right? I was still able to add something to my hash. The only thing is the issue arises with this when I try to access a key that doesn't exist, right? Because I'll just comment this in. I will put this on a multi-liner. So remember that this is just shorthand for counter at the key of char is equal to counter at the key of char plus 1, right? So notice how what happens over here is first we access counter at char, then we add 1 to it, and then we assign that value back into counter at char. But we run into an issue for the very first, for when we run into a character for the very first time, right? Because if I have an empty hash and I try to access counter at char, I have an empty hash. There's no entries in there, right? So this is going to evaluate to nil. When I try to do nil plus 1, that's going to cause an error, right? So if I give this a run, this is going to work because this return counter doesn't hit that line. But now if I give it a run, you'll see we get undefined method plus for nil class, right? Ruby's like, hey, what it basically did, right? So we'll walk through Mississippi. So we have that string Mississippi. On the first iteration, our character is M. So we come down here and we're like, all right, counter at the key of M is equal to counter at the key of M plus 1. But our hash is empty, right? If I just do that, our hash is empty, right? M doesn't exist inside of our hash. So instead of throwing that error, Ruby just evaluates this to nil. So now we try to do nil plus one. You can't add one to nothing, right? Ruby does not have to add something to nothing. You need to add something to a number. You must have like two numbers to add together, or two strings to add together. So you need to have two like compatible data types. Nil isn't compatible to be added to anything. Ruby doesn't know what addition to nil is. So to get around this, we're like, hey, instead of returning nil, return 0. So now when it tries to do counter at the key of M, it's like, all right, the hash is empty. There's nothing inside of it. I'm trying to access a key that doesn't exist. You told me to give you 0 instead of nil when I run into the scenario. So take the 0. So now we have that 0, right? 0 is a number, 1 is a number. We can add these together, perfectly valid operation in Ruby. We set that equal to 1. So now this is just notation to add a key to and a value to a hash, right? So Ruby will come up here and be like, all right, so I need to add a key of M and point this to 1.
Okay, thank you.
All right, awesome, perfect. Any other questions? All right, so I will hit reset and we'll move on to the next one, which is unique elements. All right, so this question is asking us to write a method unique elements that takes in an array and returns a new array where all duplicate elements are removed. Solve this using a hash. And they give us a little hint. All keys of a hash are automatically unique, which is perfect because that's exactly the property of a hash we'll be utilizing to solve this. So on line 7, we're passing an array of A, B, A, B, C. We're expected to return an array of just A, B, C. So all of the duplicate elements have been removed. So for this one, all we'll do is we'll just iterate over this array. And at each iteration, we'll add the current character to our hash as a key. Since we know that all keys are going to be automatically unique, no matter how many times I add a certain key, I'm only going to have one key inside the hash. So I'll iterate through this entire array. I'll add all of my keys, all of my elements to the hash. And at the end of the iteration, I should have a hash that has keys of A, B, and C. So all I'll do at the end is just call the .keys method, right? So remember from last night's lecture that the .keys method returns all of the keys from your hash in an array. And that's exactly what we want, right? If we're adding all of these elements to our hash as a key, and I'm expected to return them in an array at the end, it's all my keys from the hash in an array. So we'll just use that .keys method. So jumping into step 3, we'll call this elements is equal to an empty hash. And all we want to do now is iterate over the array. So we'll do array.each. This could be a one-liner. And we'll call this char because all of our elements are just characters. And we'll do elements. We'll create the key of the character. And over here for this question, we do not care about what the value is. The value itself holds no importance, right? We only need to assign a value over here because in order for us to add something to a hash, we must give Ruby a key value pair, right? We can't give Ruby just a key and we can't give Ruby just a value and expect it to add it to the hash. That's not how it works. You must give it a key value pair. And for this one, we just care about adding these elements as keys, right? So we're doing that, but we need to give it a value. So we'll just give it like a dummy value. We'll just set this equal to true. And we'll give this a, sorry, not give it a run. Yeah, we'll do a return elements.keys, right? So if I give this a run, you'll see we get this ABC. And I guess before I show you guys everything, it might be helpful to print everything up. So we'll do P elements. So if you give this a run, you'll see that we have this array of A pointing to true, B pointing to true, C pointing to true, right? And that's exactly what should be there because for every single key, we're assigning it the value of true. And you can see that if I change this value to be false and we give that a run, it'll still work, right? We still get that array of A, B, C because every single element still got added to my hash as a key, but now it's just pointing to a value of false. I can completely change the data type and set this equal to a string of nonsense. And if we give this a run, you'll see we still get the right answer, right? And that's because we were still able to add all of the keys to our hash, and they all just point to that dummy value, that dummy string. I can change this up. I can point this to a number, a random number. We give that a run, and you'll see that we still get the right answer, right? And that's because I was able to add all of my keys to the hash, and that's all that matters. I must be able to add the keys to the hash. If I try to just do this, and I would give this a run, we're just going to see an empty array and an empty hash, because this is notation to access a key, access a value from a hash by the key, right? This is how we access values from a hash. This is not how we add values to a hash. If we want to add a value, we must give it that equal, and we must give it a value. Nice. Any questions about this one? Okay. Looks like there are no questions. So I will hit reset and we'll move on to the next one, which is element replace. All right, so this question is asking us to write a method element replace that takes in an array and a hash. The method should return a new array where elements of the original array are replaced with their corresponding values in the hash. Okay, so if you look at our sample inputs, on line 5, we define an array with the elements LeBron James, Lionel Messi, and Serena Williams. And on line 6, we define a hash of Serena Williams pointing to tennis and LeBron James pointing to basketball. We pass both of these into our method, and we're expected to return an array containing the elements of basketball, Lionel Messi, and tennis. So all that basically happened was that any element from our array that existed inside of the hash as a key got replaced with its value. So LeBron James exists inside of the hash as a key. So we replace LeBron James with basketball. So all we'll do for this one is we'll just iterate through the entire array and see if the element exists inside the hash. If it does, we'll replace it with the value. If not, we'll keep it as is, right? So Lionel Messi does not exist inside the hash. So Lionel Messi stays as is. Serena Williams exists inside the hash as a key. So we replace her with tennis. So yeah, that was a solid high-level overview. We'll define a new array. We'll just call this new underscore array is equal to an empty array. And we want to iterate over the array that's passed in. So we'll do array dot each do pipes, and we'll call this block parameter LE, just because up here we have athletes and down here we have animals. Not really a correlation between the two, right? I mean, I guess they are like living organisms, but like, who cares? We'll just call it LE. So what we want to do is see if the element exists inside of the hash as a key. So we'll do if hash dot has underscore key question mark. Now we'll pass in the LE. We'll put our end keyword and what we want to do in this case. So this, remember from last night's lecture that this has underscore key method, all it does is it will look inside of this hash for this element as a key. So if it evaluates true, that means it found the key. So what we want to do is grab our new array and shovel in the value at that key. So we'll do hash at the key of else. So we do want to handle the case when this is false, that the value to false, right? And in that case, what we want to do is just keep the element as is. So we'll do new underscore array, and we'll just shovel in the element. And at the end, we'll just do return new array. So we give this a run, and known as tennis board. Awesome. Any questions about this one? All right, it looks like there are no questions. So I will hit reset. I'll stop my screen share. It's 7:01. Does anybody want a quick break? If anybody wants a break, just let me know. We'll take a quick 5-minute break. If not, we'll just jump right into lecture. Anybody want a break?
I'm okay with jumping ahead. I don't need a break.
Awesome. All right. Let me just set up lecture. And see if anybody wants a break. Okay, looks like nobody wants a break. All right, so I will share my screen so we can just go ahead and get started with lecture. VS Code share. Can everybody see where it says week 2, day 4, advanced enumerables, and then a whole bunch of blankness?
Yeah.
All right, awesome,
Yeah, I
perfect.
can
Thank
see
you.
it.
Thank you, guys. All right, awesome. All right, so the topic for today's lecture is going to be advanced enumerables. So on Monday, we learned about enumerables, right? And what they did was provide us a cleaner alternative to while loops for certain use cases. These use cases were having to iterate over an array or a string, right? And all they did was give us a cleaner alternative, right? These advanced enumerables are just helping us take certain patterns that we use enumerables for and take our code cleanliness to another level. So let me just write that down. So the first enumerable we'll be going over is the dot map. I'll show you guys how a common pattern that we use a dot each for, how we do something with that way, and then I'll show you guys how it's done using the dot map. So let's say we have an array. Oh, well, sorry, let me just write array here, dot each way. And then let's say we have an array of the elements A, B, C, and D. And all we want to do is just uppercase, return a new array where all elements of this original array have been uppercased and exclamation points have been added to the end of all of them. So all we really have to do for this is create a new array. So we'll do new array is equal to an empty array, and we'll do array.each, open curly brace, pipes le, new array, and we'll shovel in le.upcase plus 3 exclamation points. Nice. So at the end, we'll just do p new underscore array. Of course, if you were in a method, you would do return new array, but we're not, so I'll just print this out. Let me pop open the terminal, move this to the right, expand this out. Ruby, W2D4. Nice. So you'll see we got this array of A, B, C, D, but now every element has been capitalized and exclamation points have been added to the end of all of them. So this is already a pretty clean way, right? Compared to like a while loop, there's only 3 lines of code, but it's not enough for programmers. We're always striving to write cleaner code, mostly because we're lazy. So in comes the dot map. So the way the dot map works is that it creates a new array for us under the hood. We don't see this array being created but Ruby will push whatever the last line in the .map evaluates to for each element into that new array. I know that's a mouthful, so we'll just break down this statement through the examples. Let me just put that down. So let's redefine that array. So array is equal to A, B, C, and D. And to use a dot map, all we have to do is do p array dot map, open curly brace, pipes le dot uppercase plus 3 exclamation points, close curly brace, and that's it. So now if I give this a run, you'll see we get the same exact output. And now this is only just one line of code compared to 3. So if you look at the differences between these two ways, up here, I defined an array explicitly, right? So inside of my .each, I had some place to point to tell Ruby, hey, like whatever change I make to these elements, put it in this array that I defined. Like here's the array, and then I returned that or printed that array at the end. Down here, I created no array, right? So the .map creates a new array for us under the hood. So Ruby's like, oh, you're using the .map. You're using it because you want to do something to every element and return that as a new array. So it's implied behavior. So all it does is it creates that new array for us under the hood. And all we have to tell Ruby is the change that we want to make to each element or for each element. And Ruby will go ahead and make that change for each element and add it into the new array. And once the .map is done running, it returns that new array. And then we just print it out all on the same line. Any questions about this one? How does .map works? All right, looks like there's no questions. All right, so let's take a deep look into the second half of this statement, right? So it says, but Ruby will push whatever the last line in the .map evaluates to for each element into that new array. So we don't really see an issue with this when we write this out as a one-liner, since this line of code is our first and last line of code. So we can clearly see what Ruby will push into the array. But just like any enumerable, the .map can be written as a one-liner and a multi-liner. So we have to be careful of the multi-liner .map because that's where things can get weird. So let's try to do the same thing. So we'll do result is equal to array.map, do pipes le, and then we'll do le.uppercase plus 3 exclamation points. And right after this, we'll also just do le plus the string multi-line. So since this is the last line, this is what will get pushed into the new array. So if you put our end keyword and we print out this array, so we do p result. And if we give this a run, you'll see that we now get an array of A multi-line, B multi-line, C multi-line, and D multi-line. And that's because this is the last line of code, right? This line dictates what gets added to the array, not this line, although this is what we wanted. And this is like a very simple example, so you can clearly see what's wrong with that. You could just be like, you could just flip the order of these and it'll work. And that's true, but imagine if you have a .map where you're using like if conditionals, right? And those if conditionals have like some nested else ifs or something like that, right? It can get kind of hard to track about what the last line of executable code is for a single piece of data, right? Because there's so many ways that it can go if you have multiple if and else ifs, and if those have like nested conditionals. So if you're ever using like the .map and you're seeing that your array is not holding the elements that you expect it to have, it's because the last line of executable code is not what you think it is for that piece of data. So that also does not mean that this line of code doesn't run, right? Although all we see is the array, we don't see this. That doesn't mean that this line of code doesn't run. The only reason we're not seeing anything with this is because we're not storing it in a variable, we're not printing it out, we're not doing anything with it, right? We're just doing this addition and then we'll be just moved on to the next line. So if I put a print statement right before it and we give that a run, you'll see that we see our elements printed out, right? This is what we wanted in our array. So you'll see that this line of code still does run. Ruby doesn't just skip over it and go straight to the last line. It will run every line of code as long as it's not nested in like a false condition. Any questions about this?
So should we only use .map for more simpler like arrays than more complicated code?
It's really used for this pattern of when you want to make changes to every element in an array. So it could be a complex change, it could be a very simple change. I would say to start off, only do it for simple changes, right? Like over here, this example is very simple, right? All we did was just uppercase elements, add exclamation points to them. As you get more comfortable with the .map, you can move on to more complex changes. I would say just don't like jump right into the complex changes because it can get very confusing, especially as a beginner. I know when I first started, I stayed far away from the .map, but it would have been much better if I just eased my way to learning it and then moving on to the complex examples.
Okay, thank you.
Awesome. Any other questions? All right. Looks like there's no questions, so I will comment this up and we'll move on to our next enumerable, which is the dot select. Let's just comment this array. Let's get some spaces in here. So the dot select is our next enumerable. So the dot select is similar to the dot map in that it creates a new array for us under the hood. We don't see that array being created, but it's different in that Ruby will push whatever element evaluates to true into the new array. And that's because for the dot select, you need to give it a conditional. This conditional can be as complex as you want it, or it can be as simple as you want it. It just needs to evaluate to a Boolean, and that's all Ruby asks. And you can basically just think of this dot select as like a filter. You can think of it as like, let's say you have like a drawer of socks and you want to take all the socks that are red and put them inside of like a new drawer. So you'll pick up a sock and you're like, all right, is this sock red? No, so you don't do anything with it. You pick up another sock, like, all right, is this sock red? It is, so you add it to another drawer. You can basically think of the dot select as doing the same thing. So let me write this down as a comment. So I'll show you guys an example using the dot each, and then we'll see how it looks using the dot select. So the dot each way, we'll do array is equal to an array of 1, 2, 3, 4, 5, 6. And let's say we wanted to return an array containing all of the even numbers from this original array. So that would be an array of 2, 4, and 6. So using the dot each, this would look something like this. You would do evens is equal to a new array, and then you do array dot each do types num, and then if num mod 2 is equal to 0, we'll grab our evens array and we'll shovel in num. Then put our end for the if block, end for the dot each block, and then we'll print out our evens array. So let's clear this up. And if we give that a run, you'll see we get that array of 2, 4, and 6. Awesome. So this is already pretty clean compared to like a while loop, right? This is only like 2, 3, 4, 5, 6, 7 lines of code, right? But it can be cleaner using the dot select. So the dot select way, let's just redefine that array, 1, 2, 3, 4, 5, 6. So all we have to do for the dot select is do p array dot select, open curly brace, pipes num mod 2 is equal to 0, close curly brace. And that's it. If I give that a run, you'll see we get the same exact output. And now this is only a one-liner compared to 7 lines of code. So definitely a lot cleaner. And if you look at the differences over here, up here using the .each, I defined an array. So I had some place to point to tell Ruby where to put the number. Down here, I didn't define an array. The .select created that array for me. So I was like, all right, whatever you tell me to add to this array, I will add. And as far as the conditional goes, I had to put the if keyword and then the conditional and then the corresponding end. Down here, I didn't put an if keyword, right? So I had to put an end. All I have to give the .select is a conditional expression. This expression just needs to evaluate to a Boolean. This can be as complex as you want it, or it could be as simple as you want it, or it could be like a method call, right? As long as it evaluates to a Boolean, that is all Ruby asks for the .select. One thing to note over here is that the .select does not allow you to modify the elements as you're adding into the new array, right? Notice I'm not telling Ruby anywhere to put num, right? All I did was give it a conditional. So if you want to like modify the elements, you can iterate through the .select after it's done iterating using like a .map or like a .each to make changes to the elements. But yeah, any questions about this?
Sorry, can you repeat that last part? You said if we wanted to modify the elements, are you saying we could use select and like use both of them?
Yeah, so what you can do is just first filter out all the elements by using the .select, and then once it's filtered, you can use a .map to iterate over that new array and then make the changes. So that will look something like this. Let's say we'll just call this new underscore array is equal to this, right? So we can store whatever the .select returns into a variable, right? If I do p new array and I give it a run, you'll see we get that same array, right? So we're able to store these in variables. So now what I'm able to do is I'll just do p new array dot map, open curly brace, and let's just say I wanted to multiply each element by 2, right? So inside of this, I'll call this num, and then I can just do num times 2. And if we give that a run, you'll see that I get 4, 8, 12. So every element from 2, 4, 6 got multiplied by 2.
Got it. Okay, thank you.
Awesome, no problem. Any other questions? All right, so we'll move on to the next thing. So just like the map, I'll take out this part just because that's the map. So we'll keep that over here. Just like any other enumerable, the .select can be written as a one-liner and a multi-liner, right? So the one-liner is pretty simple because we can clearly see the conditional that'll dictate whether an element gets added. But things get tricky when we have a multi-liner. So we have to be careful of the multi-line .select. Let me write that down over here. Be careful of multi-line .select. So we'll do result is equal to array.select do, and then pipes num. And then we'll do num mod 2 is equal to 0. So this is the condition that we want. And then right after this, we'll just put the true keyword. And since this is going to evaluate to true for each element, we'll see all elements in our array. So if we put our end keyword and then we key result, and if you give that a run, you'll see we just see every element inside of the array, right? And that's because Ruby evaluated to true for each element. Although we didn't use the actual num. So one thing about all of these enumerables is you are not obligated to use the block parameter inside of your actual code, right? So I have no obligation to use this num. I can use it if I want. I can completely not use it if I don't want to. So over here, you see that I put this true keyword that doesn't depend on this num at all, right? This is a data type on its own. So I just put the true keyword. And like I said, the dot select, all it asks is that you give it an expression that evaluates to a Boolean. And true is always going to evaluate to a Boolean because it is a Boolean, right? So all Ruby does is it goes through this array. So it's like, I'm going through 1. Do I need to add it? True. So it adds it. 2. Do I need to add it? True. It adds it to the array. Then it moves on to 3. It's like, do I need to add it? True. It adds it to the array. Then 4, then 5, and 6. All of those evaluate to true. So Ruby goes ahead and adds them to the array. So if I change this to a false, you'll see that nothing will get added to the array now. So we just see an empty array because Ruby just evaluated to false for each element. That also does not mean that this line of code doesn't run, right? Ruby still runs all of these lines one by one. So if I put a print statement right before it, you'll see that we get a false, true, false, true, false, true. And then we get that empty array at the bottom. So we do need to be careful of the multi-line dot select because it's not really too apparent over here, but it can get tricky if you have like if and else ifs inside of your dot select or any multiple lines of code. Any questions about this? All right, looks like there are no questions. So I will comment this out. And that is the last thing I had for the lecture. So I will stop my screen share. I'll split you guys up into breakout rooms so you guys can get started with pair programming. Let me send you guys these notes in Slack so you guys can have access to them as you guys are working through tonight's problem set. Let me upload these notes. All right, let me split you guys up into breakout rooms. I'm about to go ahead and open up the room, so go ahead and join them and then get started with pair programming. You guys will be working on the problems under week 2, day 4. I will keep the Zoom call open until 9 o'clock, so feel free to stick around until then. If you guys are done earlier and just want to leave, feel free to leave. Completely up to you guys. If you guys finish stuff under week 2, day 4 pretty quickly, you guys can feel free to go through like older problems or like anything that might have like troubled you. You guys can like do that with your pair and see if it helps. And if you guys get stuck with any questions, please shoot me a message on Slack and I will go ahead and join your guys' breakout room and help you guys out. But yeah, I'm about to open up the rooms. Have fun pair programming, guys.